Hello everyone, I am Hitesh Setwa. Today I am going to explain in packet switching. So in packet switching, first we see the switch network. So in switch network, we can see that our network is a set of connected devices. A switch network consists of a series of interlinked nodes called switches, and then switches are devices capable of creating temporary connections between two or more devices linked to the switch. This about the switch networks, and we can see that the figure of switch network. So next we can see the taxonomy of a switched network. So in switched network, three parts of switched networks are there. First is circuit switched network, second is packet switched network, and third is message switched networks. So in packet switched network, two types are the datagram networks and virtual circuit networks. So in this video, we are going to study about packet switching network. So first is packet switching, and in this data network, datagram network. So first we read the PPT line. So in data communication, we need to send a message from one end system to another. If a message is going to pass through a packet switch network, it needs to divide into packets of fixed or variable size. So in this we can see that the datagram packet switching is also known as the connectionless switching, and datagram switching is in this each independent entity is called datagram, which means the data is divided when the data sender can send each data divided in some pieces, and these some pieces are known as the datagram. Datagram have destination. So datagram contain destination information, and the in intermediary devices uses this information to forward datagrams to right destinations. In datagram packet switching approach, the path is not fixed. In this, the path is not fixed. So in datagram network, intermediate nodes take the routing decisions to forward the packets. So first we can see the datagram network example. In this figure we can see that the A is sender and X is receiver. A sends the data and X receives the data. So in this first data sender sends the data, and one number data is going to some way, two is going to some another way, three is going to some another way, and four is going to some another way. Then and then routing, and then each data have different route. Because of this is the connection less. So all data have different routes. then routing are there, routing table. So a switch in a datagram network uses a routing table that is based on the destination address. And then and in example datagram example, this receiver routing and r- routing is defined how to reorder the received data because of the 1 2 3 4 numbers are there, and 1 2 3 4 are the sequence number. Now in this efficiency and delay, the efficiency of a datagram network is better than that of a circuit switch network. So total delay in total delay equation, total delay equal to 3t plus 3 tau plus w1 plus w2. We can see that the figure of the delay. So in first the figure, transmission time A, and then waiting time, and then time and B. So total delay is measured. So in this, switching in the internet is done by using the datagram approach to packet switching at the network layer. Now we are going to virtual circuit networks. So in virtual circuit network is a cross between a circuit switch network and a datagram network. And virtual circuit network is also known as a connection oriented network because it is depend on the proper route. In the case of virtual circuit switching, a preplanned route is established before the messages are sent. So in this route, so in virtual circuit networks, routes are predefined, and in this, call requests and call accept packets are used to establish the connection between sender and receiver. So request and accept packets are for generate connection between sender and receiver. And in this, before sending the message, some route is designed using some virtual circuit identifier. And in this rules designed based on the availability. So in this approach, the path is fixed for the duration of a logical connection. Now we are going to know about the addressing. In this addressing, two types of addressing are there: global addressing and virtual circuit addressing, virtual circuit identifier. So we can see that this figure is for virtual circuit identifier. In global source, a source needs to have a global address, an address that can be unique in the scope of the network. And virtual circuit identifier is actually used for data transfer. Now we are going to see about the three phases in this. So three phases are data transfer phase, setup phase, and tear down phase. So in data transfer phase, to transfer a frame from a source to its destination. In setup phase, switch creates any entry for a virtual circuit. So in example, we can see that the a any source is A creates a needs to create a virtual circuit to any source B. Now in this efficiency and delay, we can say that the resource resource reservation in a virtual circuit network can be made during the setup or can be on demand during the data transfer phase. So in, in this we can see that the resource reservation in virtual circuit. So next in a virtual circuit network there is one time delay or for setup or one time delay for tear down. In and that formula is total delay equal to 3t plus 3 tau plus setup delay plus tear down delay. And then if resources are allocated during the setup phase, there is no wait time for individual packets. And in last we can summarize and differentiate that datagram switching and virtual circuit switching. So in datagram switching is connectionless, virtual circuit switching is connection oriented. Data transfer datagram switching no reservation has no reservation. Virtual circuit has reservation. Datagram switching is out of order and in virtual circuit switching in same order. So in datagram switching is used in internet and virtual circuit switching used in ATM and etc. So this is all about the packet switching. Thank you.